If you use images to get from here to here, SightLine³ and the twin ray system should interest you. In this example, we're going to solve the perspective of this commercial building and use the result as a reference for quick modeling. We'll walk through the full process. First, I've added a camera. Switching to camera view, you can see there's currently no background image loaded. The active camera name is displayed here. Now I'll load our reference image. Before placing guides, I'll briefly highlight a few controls, visibility, and target options just to orient you. For architectural scenes like this, I'll enable vertical assist guides, which are especially helpful when working with clean vertical edges. For this initial solve, we'll leave the principal point set to the default fixed center. We'll set camera distance and reference height in a moment, but first we need to establish our twin ray anchor. Now I'll set the camera distance to approximately 36 meters, roughly across the street. Next, I'll enter a reference height of 22 meters, a reasonable estimate for a 6-story commercial building. Now I'll enter Edit Guides mode. I'll begin by roughly positioning the guides to match the building. Now we refine. I'll zoom in and precisely align the bottom Z anchor so the ray runs exactly along the building corner. On the lower left, I'll adjust the guide so the ray sits cleanly along the sidewalk. I'll repeat that on the lower right. Next, I'll carefully refine Z-top, ensuring the ray follows the full vertical edge of the building from bottom to top. Then I'll fine-tune the upper right corner. And the upper left. Now I'll refine the left vertical assist guide. The right vertical assist guide. Zooming out, you'll notice the world vantage point targets are not yet aligned with our twin ray guide indicators. To correct this, I'll drag the principal point downward. As I do, watch how the world vantage point lines begin to align with the twin ray guide directions. Now, the world and image perspective are closely aligned. I'll exit edit mode. You can see that the world rays and twin ray rays are now closely in line after the solve. Next, we'll reposition the twin ray anchor to our intended world location. I'll set the 3D cursor to the world origin to bring everything into alignment. We'll dolly along the Z-axis. Right-click to confirm. Lock the solve to prevent accidental changes during modeling. Hide the twin ray guides to clean up the view. Now let's test the result with some quick layout work. I'll add a 2-meter plane at the world origin, then offset it so its forward corner aligns with the building edge. To demonstrate the solve's accuracy, I'll extrude the plane upward to the top of the building. Now I'll adjust the right edge to match the building's right side. And the left edge to match the left side. Switching to object mode, I'll open the item panel. You can see the plane's height closely matches our estimated 22 meters, and the width proportions align well with what the image suggests. From here, I'll do a bit of quick modeling. I'll add a few loop cuts and reposition them to create a panel representing a window. While I'm doing this, it's worth briefly noting the benefit of the twin ray system for images like this. Twin ray allows us to work directly with edge relationships rather than relying solely on traditional vanishing point manipulation. The guides represent structural intent, horizontal, vertical, and depth directions, which makes refinement intuitive and visually diagnostic. Because we're aligning rays directly to architectural edges, we can immediately see whether the solve is converging correctly. That clarity is especially useful in scenes with strong linear structure like commercial buildings. To demonstrate depth alignment, I'll recess the window slightly to make this easier to see. I'll reduce the image opacity, and you can see that the recessed window maintains correct perspective, confirming that the solve is accurate. Thank you for watching. This is SightLine³. You'll find links below for more information.